Okay, so we'll start the lecture with an announcement. We'll pick up roughly where we left off yesterday with GitHub and hosting your website, and then there will be some new stuff on how to get animations running. At the end, any time that's left over, maybe we'll do a quick demo on starting your Lightning assignment, putting all the ideas together from the past week or so. So there's this first announcement. There is the Astronomy Club is leading a collaboration amongst a whole bunch of clubs at Lowell. Dev Club, EECS, Girls Who Code. They're all working together with the Lawrence Berkeley National Lab to do some pretty neat research. So you can watch a video linked in this slide. Take a look at what they're advertising. There is an info meeting, I think it's today, at 2:30, so that's after Reg. Get cut off. Okay, recording looks good. That's today. There's the Zoom link. So this is the AP Java processing slide deck. EECS, I think, meets Fridays. You can email me and I'll forward you information. Girls Who Code is going to start meeting Tuesdays from 2:15 to 3:15. I'm unsure when these two clubs meet. No, I only know these two because I'm the sponsor for these two clubs. Okay, so a point that was mentioned yesterday, because one of you had the problem, or 2 days ago, one of you had this problem where you dragged the processing.exe outside your folder, and suddenly everything stopped working. The folder structure, or the file structure of processing and in GitHub is really important. So in processing, the name of your PDE file, that's where all your code lives. PDE is a processing specific extension. It has to live in a folder that matches its same name. Okay, that's mentioned already. So when you download a processing, like this is the Windows version, processing.exe, it lives here. If you need to move it somewhere else, create a shortcut and drag that along. The GitHub folder, we kind of skipped this step because Mr. Simon and I have simplified the workflow because we're not physically in a lab. So you don't really have a GitHub folder on your computer. The main ways you're interacting with it is on the GitHub website. So inside that repo, right, on the GitHub website, these are the important files you should know. The index.html, that name has to be the way it is, index.html, that's your web page. The processing.js, this is what lets our code run in our web page. We won't be changing it at all. The README has instructions, it has hints, that's like given to you, you made a copy of it. You won't modify that for the most part. The main place where you'll be making changes is the PDE file, like for the Lightning assignment. It looks like lightning.pde, that's where you're going to copy and paste your code. The styles.css, if you have some extra time, you can play around with this to change the font, the colors, some other things, the spacing of your website, but it's not going to be formally taught in this class. Now, absolutely don't change the file names, okay? They're there for a reason. And then it tells you why. So some of the neat features in GitHub, right, is, or in a GitHub repo, is that it shows you the history. So Mr. Simon calls it with superpowers, right? Like in a Google Doc, in the last like 6 or so years, they added the view version history feature. GitHub had that since like forever, right? GitHub is this more general like version control software that helps developers keep track of their changes, making sure nothing's broken before like shipping out a product. So a little bit more about those commit messages. Because GitHub remembers each history, that's why it's like more specific than just save, it's commit. You noticed when we went and committed everything, there was a default message here that was just like updated blank file. You could add on and change that. You could add an optional description and detail on what your changes were, or you can change the short description on what you did. That way, if you go back to it, you can see like, this is when I changed this feature. This is when I added the loop over here, and suddenly my code broke, right? So you can backtrack and see your previous work. So these screenshots are pretty good. I don't have to switch to another window, but we clicked on the pencil yesterday to make changes to a file. If you click on history, you'll be brought to this screenshot on the right-hand side where you see when things have been updated, like each commit that you've done. So let's say that you finished your Lightning assignment. You have to navigate back to this GitHub pages, which I had trouble finding for this Block 6 class the other day. You got to scroll down from the options after you click on settings, right? This is the website that you'll be submitting. We've already made these changes, master, and we saved so that our website is live. And it's this thing that will post to Google Classroom. So a little bit of logistics, right? Some visual reminders on the left on what to click on, your website. It'll be really helpful for both me and Mr. Simon's class that in the corresponding assignment, like in Lightning, that you click on add and add a link. That's where you're going to paste this apcslol.github or whatever your username is / something. That's what you're going to post here. And it's really handy if you click the turn in button so that we know you're ready to be graded. Although after the deadline, it doesn't matter what you did. I will cycle through all of it and give you a corresponding grade unless you've asked me for an extension. But just as a tip, right? It organizes things on your end as a student too, so you don't have late notifications or work that's pending. Click the turn in button. It will really help us. Okay, so that's the general GitHub stuff. Any questions on getting that set up? Or short? Nope. Okay, so we'll start, we dive back into code. You may want to have your processing IDE open, the processing tool, so you can run some of these changes. I will do that at the end because I think these slides are, like, it has everything we need. So let's see, in week 1, we talked about variables. Now we're going to use them because now they each have purpose, they have jobs. We're going to use variables to help us with animations. Variables, you've seen that in math class. The root word is vary, meaning change. And that's what we're going to use to help us, okay? They're essential in the animation process. So over here, we see an animation. Circles that start on the left and move to the right. Notice the use of int x, initialized and declared here in line 1. That's what helps us draw and moves the circle across the screen. But if you look carefully, you'll notice, wait a second, there's no loop. How come the circle is being repeated again and again? Well, the draw loop, or the draw function, is an invisible loop. It repeats itself again and again and again. Some of you, you're familiar with the infinite loop. Well, that's what the draw is, right? But except it doesn't really crash your program. So let's see. So lines 1 here and line 9, right? There's the usage of the variable. We're familiar from line 1 of this initialization and declaration, but line 9 is the step that we focused on as we practice loops, like in your worksheet. This is updating, right? In code, it's like kind of weird. In plain English, its job is to update x by 10 pixels. When we use it here in the ellipse function, that's what causes it to move to the right. Notice the change. We've moved the initialization and declaration step into the draw function, right? The invisible draw loop. Notice now you don't see the circles. You don't see the animation anymore. Why is that? Well, each time you repeat, you've initialized and declared it each time. Starts at 0, draw a circle at 0, 150, update it, and then the next time it repeats, well, you initialize and declare it again. So you reset it to 0. Draw your circle, increment it, reset, draw, so on and so forth. So there is no movement, but there is circles being drawn on top of one another again and again. So with the help of the while loop, right, we're putting loops inside loops. It's a big idea for the AP test. but so we'll start with it now visually, understanding like what the heck's going on. So you know that while loops repeat, but if we put them inside the draw function, the while loop finishes first, and then the draw loop goes. Okay, the draw, think about it as it happening over time, versus the while loop happens in an instant. So you'll notice in this example, right, as soon as we click play, there are a bunch of circles drawn to the screen. You don't even see the animation. And those, like what, 30 circles, concentric circles, are being drawn again and again, but they're in the same exact place, but we see that instantaneous loop happening. Yeah, that's the while loop inside the draw loop. Now compare that to this one. Okay, you see the circles being drawn, they're growing, coming out from the center. Notice the difference between the lines of code. So one, where you get it one at a time, uses just the invisible draw loop. This one right here. This one uses a while loop inside the draw loop that does that instantaneous or immediate effect. So we can slow it down to make it a bit more obvious that it's actually happening, and that's with the frame rate function. So this one has the draw function loop itself one iteration at a time, one screen at a time, each second, right? By default, I think it's 60 frames per second, so that's why you don't see it, but once we slow it down, you should see a difference. Is it here? Kind of. The code example changed. Blast. But you notice like the rings that are happening here, they're moving much slower. I think this is the same code. Kinda. It's a little arranged differently. There's more spaces, but you see the idea, yeah? And then there's some new stuff that resets it, which keeps it kind of like repeating. It's kind of weird because I stared at it for a while. There's like some kind of illusion or trick on the eye that's happening that has the circles like remain. That's not actually there. So then we're putting the ideas from Unit 3 with if statements into our drawing. There's this resetting idea. When your diameter gets too big, reset it back to 10. Be small again. This one's kind of neat. So the new part is fill controls color. But if you add a fourth argument here, a fourth input, that controls opacity, which is the see-throughness. The intensity each pixel is like dialed down a bit, so then you see this kind of like fading effect that happens from the center as it goes out. Trippy. Doing pretty neat stuff now. And you see already we've introduced like there's a rectangle happening here that covers it from before, that lets the see-throughness happen. We've seen new functions like fill, stroke, right? Like where did all these functions come from? Well, they came from here. If you go to this website, you should definitely bookmark it, processing/right. I'm trying to hypnotize you all. So processing.org/reference, right? This website's super handy. It lists out all the awesome functions that processing offers us. And for now, we'll stay in the shapes or 2D primitives features, right? That controls and drawings, color, stroke, all those fancy things, colors, shapes. Okay, formally it's called an API. I forgot what it stands for. But for us, it's like a dictionary. It tells you what this function is, what it does. Here's some examples, so then you can learn from it. Ah, there it is at the very bottom in black. Application Programming Index API. So for the lightning assignment, we'll be using the line function. So then we clicked on it. We see that it takes in 4 things. It gives us a paragraph on what it does. Cool, 2D coordinates, great, X, Y. Oh, it even does 3D. And it draws it. It has, what, X, Y of the start, X, Y of the stop, there, and there. Then it connects it. Stroke, right, is the color of your, like, if you think about it like a paintbrush, okay? If you don't put much pressure on it, it draws the line like by default, yeah? If you press harder, you're adding more weight to your stroke, then it gets thicker. So then you see up here the red line that happens first. Why is it red? Well, R, G, and B. This is the red index, the red intensity. So then that line's drawn of stroke weight 3, and then it gets thicker and thicker. The next line is green, G, and then the thickest line, blue, down here, most pressure, 20 whatever units of intensity, pressing really hard on your paintbrush. We're all familiar with RGB from our prior programming experience, yes? Cool, I know my students are. Yeah, and the fourth one is opacity. So that's the one that got this fading effect. See-throughness, that's opacity. There's also like 2 other features of colors on the computer. I don't know what the heck they are. Opacity is the only one that makes sense. There's like some other fancy word. Some guy was trying to explain it to me and I was like, no thanks, too much. Cool. So this is like the base code. If you get this animation working with some random colors, with some lightnings and lines going from left to right, you get 4 out of 4. But since we got like another week and a couple of days on it, you may want to apply some neat ideas, try out some new functions to get cool stuff that looks like this. George is a prior student of Mr. Simon's. He made use of the opacity, and also noticed there is like what's present. It's not instantaneous, right? You see the pixels and lines kind of go down the page. So he did something fancy in his like while loop inside the draw function. So that's where I stop. But at this point, what do you all want to see? I got about 15 or so minutes. Would you like to see more of GitHub? Would you like to see more code examples? Talk to me. Code examples, neat. Do you want, like, okay, let me revisit the student's question. They asked about loading frame by frame versus giving everything at once. Well, that's the difference between the draw loop and the while loop. So play around with how you want to, like where you use a while loop, where you use a draw loop. Or you gotta have a draw loop. It's like, how do you interact with it? Where are your if statements? Where are your variable declarations? So on and so forth. Okay, so let's dive into detail, I guess, since we asked for code examples on like what's going on with this opacity idea. So that's the lines or circles, this one from this slide. Actually, no, where's the one that fades? That's this one. Because there's a bit more happening than you initially think. So I'll try to narrate this process as I'm working through it. I'm having like flashbacks on like how long it takes for processing to like boot up, right? It was like this 10 years ago too, when it was like 2 point something. I tried to dig up my old work from like 2009, I guess, or 8, 7? No, 7 I was a freshman, so I only found like 2 assignments and they weren't very fantastic. I made like a Jigglypuff for my animal, and then for lightning, like I did the lightning assignment, but I couldn't find my old code for it. So we got a new sketch. Is this text huge? Yeah, okay, good. So every function needs a setup, needs a draw. All right. As we think about our size, default is what, 100 by 100 pixels. We'll make it a little bit bigger. Background. So Oh, yes, thanks. So let me stop sharing. Let me share my whole screen. Desktop 1. Thank you. You see the slides and the processing now, yeah? Cool. Great. Thank you. So, background. It's what you think, right? Background controls the color of the background. I don't know what more to say about that. At this point, I would run my code once just to see a 300 by 300 canvas. Oops, I pressed A. Appear, and it should be black colored. 0 is all the lights are off, so that's why it's pitch black. 255 in terms of intensity is the brightest a pixel can be, so that's why if it was all 255 it would be white colored. Cool. No fill is a useful function. By default, all the shapes that you draw, like circles, they have a filling. This one turns it off, so let me demonstrate that to those new to processing. Let's make it in the middle, right? 150 is a nice place. And we start by 2020. Circle, okay? So when we draw it, it's going to be weird, right? Like, it's there, but it's hiding because the outline is black and then the background is black. Like, that's not useful, Mr. Jan. So we'll make it bright. Fill. Not fill. Silly me. Because I want to demonstrate no fill. I meant stroke. Stroke is the outline. Okay, there it is. There's my circle. Notice if I commented out no fill, we have a subtle difference in how the shape is drawn. It's filled in with that white color. I took a little shortcut. I could have done this to get the white color, to tell the computer exactly what I wanted. But if you just put one number in, it translates it to like this grayscale idea. If I did like 155, I'd get a shade of gray. Barely gray. You can barely see that grayness. Okay. So we've made through a couple of those lines. Great, we got our white circle. Let's add back in the no fill so we just see the outlines. Ta-da, okay. So let's get it to repeat, right? Because that was the next layer of difficulty. We need a variable to help us out. Notice that we add these variables to the very top. That does matter here, okay? Later we'll talk about this idea of scoping. We put it at the very top so that this draw function knows that diameter exists. Okay, these are known as global variables. We'll talk about those later in the semester. Let's see, diameter. And it's helpful, although it's kind of worried, to have useful variable names, like calling things x, y, z, r, q, whatever, right? It's going to be confusing for you later on when you got like 100 different variables going, and then you're asking yourself, shoot, why did I do that? Diameter plus 20. Spelling. Cool. So now we should see circles that grow. One circle at a time. That was really fast. Kind of staring at it hurts my head. But we're almost done. Frame rate. Oops. Capital R. 10. So now it's a little bit slower. Boop, 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 boop. Great. Okay, now we want the fading effect. Forget the reset, okay? I think the fading is more interesting than the resetting with the if statement. So notice these two lines that happen, right? Fill, so I'm looking at the slides and just copying it over for now. 0, 0. Do all functions that are two words, like frame rate, use camel case? That seems to be the convention, yes. Notice no fill has camel case, so the first one's lowercase and the next one's capital. If you look at the reference, you'll see that should be consistent. There's some reasons what these programmers are doing. Okay, so right now it's fill, and we're drawing specifically a black rectangle using the rect function, rect. The upper left-hand corner is the 0, 0, the origin, and notice the size, yeah? It's the same as our canvas. So what we're doing is covering up what came before it. And notice right now, I didn't add the opacity argument there. It's only 3 things, so I draw a solid black rectangle. So then, when our program plays, right, you see like what? A ripple, yeah? You don't see the ones that are there from before. You may want to utilize this in your lightning assignment somehow. Really neat. Wow. And then this idea of see-throughness that happens comes from the opacity, comma 15. So when that black rectangle has some see-throughness there, right? And you like, let's slow it down even more. As you layer on top more and more black rectangles, that's the fading that happens, right? So this is super slow. Watch the center, and it gets lighter and lighter and lighter with each frame. Right? As you layer on a darker and darker, like somewhat opaque, somewhat see-through background, eventually it's gonna stack on top of it so much that it disappears, right? And you see the effect of the loop now since I've slowed it down this much. Although we don't see the circles that grow past our size or our canvas, you still see the rectangle being drawn, which is why you still see it fade this many frames out. Pretty neat, I think. Yeah. The if statement, I guess I'll work through that in these last couple of minutes just for completeness. That was one of the ideas that we reviewed, that we guess that you have. Program experience, there's diameter being less than 400, okay? And then reset, right? Diameter, set yourself equal to 10 when you've gotten to the edge. Spacing matter, kind of. What is it, Command T to reformat things? Ooh, it adds spaces. So then frame by frame, and then it resets after a certain point. Boop, boop, doop, doop. I messed up somewhere. Do you see where I messed up? It's not the same as before, so it has to be the if statement that I added. Do you see why the code is working the way it does? I don't see my circles. What gives? Help me debug this. What this does. Yeah, there we go. So right now our if statement kind of does the opposite of what we want. If your diameter is less than 400, then you're stuck at 10. It's like, no, 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 that's not what I wanted. I wanted when you get too big, then you go to 10. So really it's the opposite relationship we want. Ba-doop, 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 ba-doop. Neat. Okay. We got about 5 minutes left. Any other examples you want to see? I figured this is a neat one to kind of explain in detail on what's going on. Nope. All right, well then, you are all free to go. Those that want to stay for the last 4 minutes, go ahead to answer individual questions, but otherwise this recording's done. Have a great rest of your day.